The field may have a single winding, may have generally two windings, shunt winding and a series winding. But it's not this the issue. Here what is important is the connection between the field and the armature. We said if we according methods, yeah. So look, yes, I didn't start yet about the methods. So we are talking about the connection of those parts. So if we feed them separately, each one with different source, we call this separately excited. So let's see the different classification of a DC motor, of DC machine. So DC machine can be divided into according to their excitation. According to their excitation. Okay. According to their excitation. So we have the separately excited. So if the field and the armature are connected with different sources. And we have self-excited. Self-excited when the field and the armature are connected to the same source. Okay. Separately excited if the field and the armature are fed with different sources. Self-excited if the field and the armature are connected with the same source. And we have the permanent magnet is the case when we replace the field by an permanent magnet. Where? So the self-excited machine has a different parts. Different types. We have a shunt excited, which means that the armature and the field are connected in parallel. The series excited, which means that the field and the armature are connected in series. And the compound excited, which means that the field and the armature are connected in parallel and in series in the same time. And in the compound excited, we have two types. We have a long shunt and short shunt. However, this compound machine, we are not going to focus on it a lot. Okay, so those are the classification. I will repeat the classification of DC machines according to their excitation method. So we have a separately excited when the field and the armature are connected separately. Each one is connected to different source. Self-excited, which means that the field and the armature are connected to the same source. And the permanent magnet, when the field winding is removed and replaced by a permanent magnet. So the self-excited machines has different types. Shunt excited when the field and the armature are connected in parallel. Series excited when the field and armature are connected in series. Compound, which mean complex, which means that the field and the armature are connected in series and in parallel in the same time. We're going to see them in the next slide. Okay. This one is separately excited. We can see that the armature and the field are fed separately. So this machine is the general case. The separately excited machine is the general case. And it's the case which we deal with a lot because it's the general case. Now, self-excited DC machine. So this is when the field is interconnected with the armature winding to the same source. The machine is said to be self-excited because so it's excite itself. The field winding can be connected in three different ways. In series, so this figure, we can see the field winding connected in series with the armature. In shunt, which means parallel, we can see that here the field winding is connected in parallel. Here in the shunt configuration, we add resistance here because the shunt winding, we said that the shunt field winding, it's low current winding. So we add this resistance just to reduce the current. It's a rheostat, it's a variable resistance. We add it to reduce the current to the shunt winding. And we have the compound. So the compound, we can see that they are connected in series and in parallel in the same time. So both of series winding, field winding are connected. So if we have here generally the machine, especially the machines we have in the lab. Machines we have in the lab, they can be connected because their terminals are accessible. You can access all the terminals. So you can connect them in series, in shunt, in compound, whatever you want. Okay, that's why they have two field windings. So if the machine connected in series, we use the series field winding. If the machine connected shunt, we use the shunt field winding. If the machine connected compound, we use both of them. But in the compound, we have two types. We have a short shunt and we have a long shunt. It depends to the position. It depends to the position of the shunt winding, if it's connected before or after the armature. I hope those methods are clear, or should I repeat again? Yes. Yes, you can just take the equivalent circuit, the simplified circuit, and you connect them whatever you want. So I will repeat. Okay. So we said that if the field and the armature are connected separately, are supplied separately, we call this as separately excited DC machine. So we call it separated or independent. Each one is connected to independent source, DC source, of course. So now we have seen the classification. We have the separately excited. We have the permanent magnets. The permanent magnet does not need a power source. So because it generates magnetic field from itself, where the self-excited machine has different configuration. We can call them configuration. Shunt excited, series excited, and compound excited. And those are the series machine, where the field winding is connected in series with the armature. The shunt machine is where the shunt winding is connected in parallel to the armature, and we said we add resistance here because the shunt winding, it's low current winding, so we add this resistance to protect the shunt winding. The compound machine, it's connected in series and in parallel in the same time. So we can see that the shunt winding are connected, both of them in one in series and the second in parallel. Each type of this configuration has, of course, an advantages and has disadvantages. So we are not going through them directly a lot deeper, I mean, but just to give you an example, one of the most important application of DC machines in our real life, which is the railway and tramway. You know that they use DC machines. They still use DC machines. In most applications, industrial applications, they use AC machines, maybe 80%. They use AC machines. But in the railway and tramway, they still use DC machines, especially the series machine. Why the series machine? Because it has a great startup torque. When this machine runs, it has a great starting up torque. So it's, you know, if you think that the railway is in use alternative machine, no, it's use DC motors. Okay, especially the series configuration. Okay, it's applied in the railway and in the tramway. Those high power applications. Okay.